This is part 2 of the equation and problem solving. We'll begin at the bottom of page 159, distance, rate, time problems. No, you are not in Mrs. Little's science class. This is math class. And we're looking at distance, rate, and time. Distance equals rate and time times time. Defining the variables. We need to find that D is what is representing distance. R is what's representing the rate. T is what's representing the time. We're going to use this as we answer questions related to same direction travel, round trip travel, and opposite direction travel. Okay? Page 160 begins with example 3, talking about same direction travel. If you look at example 3, it talks about a train leaving a train station at 1 and another train leaving an hour later, traveling 18 miles an hour faster than the first one. Still not as fast as the bullet train from Beijing to Tianjin. But anyway, it's still a fast train. It talks about defining. They're telling you that T is representing the time the first train travels. Time of train 1. Then they're showing you this nice little handy-dandy chart. The handy-dandy chart is very helpful to use. I would recommend using that as a strategy. And then if you look at the first method, they continue to fill in the chart. Or you could go to method 2, which is the method I will be using, and write in an equation with variables on both sides. You guys are experts at that, so let's see how well we can do for a real life application. A group of campers and one group leader left a campsite in a canoe. They traveled an average rate of 10 kilometers per hour. 2 hours later, important info, the other group leader left a campsite in a motorboat. He doesn't get to pretend he's Lewis and Clark. He traveled at an average rate of 22 kilometers per hour. How long did it take the motorboat to catch the canoe? Okay, we're going to use T representing the time of the canoe. Everything's going to be related to that. All right, let's talk about a chart then. We're going to have G1, which is group 1, and G2, which is group 2, or just the leader. Group 1, let's set it up with the rate. How fast is group 1 traveling? 10 kilometers per hour. How fast is group 2 traveling? 22 kilometers per hour. Time. The time of the canoe is going to be T. So the time of group 2, or the motorboat, they left an hour late, no, 2 hours later. So T minus 2. However long it took them, you have to subtract 2 because they left later. So that means the distance, remember distance is rate times time, is 10 times t, which is 10t. And for this one, it's 22 times t minus 2, or 22 times t minus 2. Now, what do you think we're going to do with those two equations? Yes, we're going to set them equal to each other. So 10t equals 22 times t minus 2. Or 10t equals 22t minus 44. Variables on both sides. X. Well, I already have a t by itself on this side. So why don't I move 22t over to 10t? So let's subtract 22t minus 22t. These will cancel. Merry Christmas to you. 10 minus 22 is negative 12t equals negative 44. Okay, so divide by negative 12, divide by negative 12, and I'm left with t equals 44/12, or 22/6, or 3 and 4/6, or in most simplest form, t equals 3 2/3 hours. You could say 3 hours and 40 minutes. That's how long it would take him to reach the canoe. Example 4 on page 161, round trip travel. Again, if you notice the way they solved Noya's problem, they used a chart and they set the equations equal to each other. Let's use that problem as we talk about Miss McBride's drive to work. On her way to work from home, Miss McBride averaged only 20 miles per hour. Oh, that's creepy crawly slow. On her drive home, she averaged 40 miles per hour. If the total travel time was an hour and a half, how long did it take her to drive to work? Time of driving. We're going to call that T, time to work. Okay? So we're going to go to work and to home. Okay? Let's talk about to work. Remember, distance equals rate times time. So the rate that she traveled to work, the time that it took her, and the distance, setting up our handy-dandy chart. Here we go. At what rate was Miss McBride traveling to work? Good, Jacob, 20 miles an hour. At what rate was Miss McBride traveling home, Duke? 40 miles per hour. She wanted to get away from you guys. Now, let's talk about the time. What did we say was going to be the time that it took her to drive to work? Yes, Kenzie, T. Now, if the whole trip took her an hour and a half, how can we figure out how long it took her to get back home? It took her T hours to get to work and 1.5 total. Could we take the total 1.5 and subtract the time that it took her to go to work? Absolute. Here we go. Let's find the distance. Remember, it's the rate times the time. So 20t and 40 times 1.5 minus t. Okay? Now, let's set these two equations equal to each other. 20t equals 40 times the quantity 1.5 minus t. 20t equals, Maddie, make sure we multiply them both. 60 minus 40t. Okay, back to solving equations with variables on both sides. I have a 20t all the way over here by itself. I have a 40t over here. How about we add 40t to both sides? Those will cancel. 60t equals 60. What is t going to equal? 1. Therefore, when we look at our question, how long did it take her to drive to work? If t equals 1, is it 1 cowpoke? 1 star in the sky? 1 hour. That would be 1 long hour. Okay? The last example is example 5. It is opposite direction travel. I want you to notice example 5. They're talking about, this is on page 162, Jane and Peter. And they leave their homes and they're traveling in opposite directions. Notice they still defined the rates. Notice they still made a chart. However, notice their equation. When you're doing opposite direction travel, you're going to do, in our case, for our quick check, Sarah's travel plus John's travel is going to equal, what do you think it's going to equal? Yes, it will equal the total miles traveled. Okay, let's talk about Sarah and John. Sarah and John leave Perryville, traveling in opposite directions on a straight road. Sarah drives 12 miles per hour faster than John. After 2 hours, they are 176 miles apart. Find Sarah's speed and John's speed. Sarah. How fast is Sarah driving? She's driving 12 miles an hour faster than John. Oh, we need to know how fast John is traveling. We don't know. John is traveling J miles per hour. Sarah's driving 12 miles an hour faster. So Sarah is J plus 12. Okay? Now, the time, that's their rate. Now their time. How long did it take them to travel? 2 hours. So the time is 2 hours and the time is 2 hours. Now let's look at their distance. Rate times time. So 2 times J plus 12 and 2 times J. From there, using our formula, Sarah's travel distance plus John's distance equals the total miles apart that they are. See what you get for your answer, and we'll check it in the morning. So